Good morning. Hello and good morning. This is a short and elementary course on tribology, and I am S.K. Chaudhary. In simple words, tribology is the science of friction, wear, and lubrication in machinery. Although it sounds simple, it involves several disciplines. For example, surface physics in micro and nanoscale, organic chemistry, a fair bit of mathematics, thermal and manufacturing sciences, measurement techniques, statistical analysis, and control theory, to mention a few. Finally, we may say that a good knowledge of tribology ensures a long, trouble-free, and safe learning of machinery. However, before I go to the main topic, I'd like to discuss a few issues relevant to the present-day industrial scenario. This slide takes a look at machine learning and learning of machines. Although it looks like a tongue twister, but it has a great significance in present day scenario of industrial and technological world. It seems today the whole world is bent over backwards to teach the machines how to do our work efficiently and intelligently, commonly known as machine learning. Here, of course, by machine, we mean the computational machine. Admittedly, this is necessary not only in engineering, but also in all fields of science and technology. In the first phrase in the slide, machine learning, machine refers to computational machines, whereas in the second phrase, learning of machines, machines indicates machines, those produce goods for our daily needs and for industry and everywhere else. However, in the present overrated enthusiasm, we often forget that it is the machine that delivers the final product. And the rest of the machine learning and artificial intelligence provides control and fineness in the machining and takes away some of our human load and error. Take, for example, a lathe machine shown on the right. One of the earliest machines in the mechanical engineering that usually holds a stock bar between head and tail stalks and a tool held in the tool post moves along the length and the breadth of the rotating stock to give it a desired shape and size. On the left is shown a CNC, a computer numerically controlled lathe. There are many advanced versions of this type of machines with ML and AI incorporated. But the fact remains that the basic machining process remains the same. It therefore seems that learning machines, that is, learning how the machines work, is probably more important than machine learning. And this is where the knowledge of tribology is essential to make machines and manufacturing more efficient and safe. Now we look at a brief genesis of engineering. Engineering evolved from the needs of mankind and problems vary from space and time. And the solution techniques also vary in space and time. In different countries and different times, people have faced problems and they have solved their problems in their own ways. The earliest human society faced the problems of food and shelter, and there they needed to invent fire by simply rubbing sticks or flint stones together. This is engineering, and to be very precise, friction engineering or tribology. Depending on the climatic conditions, human society had to solve problems faced by them. For example, problems are different in cold countries from those in the hot country. And people have solved their own problems in their own ways. Now, engineers identify problems and come up with a solution, often creating something completely new in the process. Albert Einstein praised engineers and said, scientists investigate that which is already there, whereas engineers create that which has never been. This is a great compliment for the engineers, and it is indeed very true. When Newton discovered gravitation and formulated laws governing the gravitational force between heavenly bodies, we learned something completely new. And both science and the age-old faith took a different turn. But he didn't invent anything new. He simply discovered a knowledge which was not in front of us. Whereas engineers make something which was never there on the face of the earth before. For example, Egyptian pyramids, which could be as high as 203 feet high, Eiffel Tower, 325 feet high, computers of all sorts, spacecrafts, they were never there on the face of the earth. Engineers made it. So we say that the engineers make something which was never there on the face of the earth. But of course, they needed the science in the background. So the science and the engineering go hand in hand, and we need to involve both in solving our problems day to day. Now we go to the main topic, tribology. Now, tribology is defined as the science of and technology of interacting surfaces in relative motion. Whenever the two surfaces rub or slide or rotate against each other, there are two essential problems generated there. One is friction, other is wear. And this has been described by a new word, tribology, which comes from the Greek word tribos, meaning rubbing, and logy is the science. So tribology is basically the science of rubbing. But as we'll see eventually, it involves great many disciplines of science and technology to understand what happens at the interface between two sliding surfaces. It is essentially a study of friction, wear, and lubrication to stop the problem of friction and wear in engineering surfaces, engineering machines. Tribological applications are everywhere, and it includes bearings, gears, bushings, brakes, clutches, chains, human body implants and processes. It's surprising that human body consists of many sliding and rotating components, for example, knee and hip joints. And they eventually wear and create friction, and that gives us pain. And this is why in great many processes have been developed to relieve the pain. And we know it today that hip joint replacement and knee joint replacements are common today. Tribological applications are also there in seals, piston engine parts, and many other components. In fact, wherever there is a sliding surfaces, tribological applications will be there. Even in computers, there are sliding components. Sliding, rotating, and rubbing surfaces is the cause of essential problems like friction and wear. So we look at it in a different way and we try to solve it to ease our work. And this problem has been there ever since the human society has tried to develop. For example, this figure shows the transportation of an Egyptian colossus from the tomb of Tehuti Hetep at El Barsa on the east bank of Nile in 1880 BC. Even in those days, sliding or dragging posed a great problem. And obviously, a huge statue like this, compare the statue size of the statue compared to the people who are dragging it. So rows of people are dragging it, and yet they felt something else had to be done. And hence, they had tried to lubricate. Look at this fellow. He is trying to pour something in front of the statue. And this is some kind of a lubricant known in those days. In the words of Professor Duncan Dawson, this man is probably the first recorded tribologist in the history. In the next slide, again taken from the book written by Professor Duncan Dawson, History of Tribology, the Assyrians are positioning a statue at Tonjik, which is ancient Nineveh, which was capital of Assyria in northern Mesopotamia, 700 BC. This is modern northern Iraq, near the city of Mosul. Anyway, the tribological importance of this figure is this. rows of people are dragging the statue in all different directions to position it. And obviously the effort is significant. But even then, they felt something else had to be done. So they brought in small pieces of logs, you can see, and they're trying to push it under the statue. These are the logs. And objective is that these small logs would act as rollers. And even in those days, they knew or they understood that the rolling friction is less than the sliding friction. So the difference between this figure and the previous figure is that here they're trying to make the sliding easy by putting some lubricant. And here they're trying to make them sliding easy by pushing some rollers. So roller makes it easy in terms of rolling friction, and sliding is made easy by lubricant. These are the two very important understanding needed in tribology. And it seems that in the earliest civilization made an attempt to understand this, although not by any mathematical or analytical means, but by simple practice. Now we look at the industrial importance of tribology. As we said, all sliding or rotating machines need to overcome force of friction, and they wear out eventually. It is important to know that approximately 1/6 of world's energy is wasted in friction. The figure is approximate, but even then it is an astounding figure. And this much of energy is wasted in friction. And if we can reduce this using good tribological practices, then we have saved energy. And energy saved is energy gained. So in a way, we can say we have created energy. With due regard to good tribological practices, the energy may be saved in industry and even in our day-to-day life. This course tries to understand how this is done and what are the effects of this in our industry and in our everyday life. There is also a great deal of wastage due to wear of machine parts. Those who are remotely involved in the industrial practices would know that almost every day millions of machine parts are thrown away because of the wear. When the parts wear out beyond the replacement, beyond the repair limit, then they are thrown out and replaced. So if we can find out ways and means of reducing wear to a level where it need not be thrown out, we would have saved a great deal of finance, in the industry, and elsewhere. Now we look at the tribological system. Now, a tribological system shown in the central rectangle here consists of mainly three things. Number 1 and 2 are the two sliding surfaces. 1 and 3. 1 and 3 slide against each other. And 2 is a lubricant. Now, for many people, lubricant is a bucket of oil. It is not so. Lubricant can be solid, lubricant can be liquid, lubricant can be gas. Air is a good lubricant, carbon dioxide is a good lubricant, and also milk is also a good lubricant. And also, if we put a handful of grate between two surfaces, surprisingly, that also may act as a lubricant. Why? Because the grates would act as small rollers and allow the two surfaces to slide with rolling elements between them. It is our common experience that we often slip if there are grates under our feet. Anyway, so a tribological system consists of two sliding surfaces and a lubricant. Number 2 is a lubricant. Number 1 and 3 are the sliding surfaces. This is what the Professor Post-Sequence thought of, making this tribological system a system analysis. He defined structure of the system S as a matrix of A, P, and R, where A is the set of elements, P are the relevant properties of the elements, and R is the relations between the elements. Now, A and P are okay, but the problem lies in relations. We'll see that later on. In a tribological system, there are some input and there are some output, use output, and there are some loss output. Input may be types of motion. We may have a linear motion, rotary motion, circulatory motion, vibratory motion. We may have load, velocity, temperature, time, and material flow. And we have use output, motion again. If you take a slider triangle mechanism, we convert rotating motion to a sliding motion. We may have information if we use certain machine. We may have energy output, and we may have materials again as output. But whatever you do, input and output, there is always a loss output. The loss output are two, the friction and wear. Now, Professor Sequence felt that this system can be analyzed as a system matrix. So he thought that we may write input matrix X equals to a transfer matrix T and output matrix Y. This is fine, it looks okay. But the problem would be in transfer matrix. And this is where a huge amount of experimental or empirical data is needed. And for hundreds of years, people have been doing this. They have been relying on experimental results and trying to simulate and model friction and wear. But nevertheless, a system approach would work to an extent, but experimental and empirical data are essential. I felt that Professor Hossicker's approach to tribological system would be useful one day, and we may come up with a useful transfer matrix for any individual tribological system. But till now, we depend very much on experimental and empirical data. This slide, I have written whatever I've just said. System consists of three main things: two sliding surfaces, 1 and 2, and 3 here is the lubricant. 4 is the atmosphere. It's very important because if you slide two surfaces in vacuum, you'll find that it's extremely difficult. Friction is very high. Why is that? Because there is no lubricant between the two surfaces. Whereas if you slide the two surfaces in air, you'll find it's not so difficult because the atmospheric contaminant acts as lubricant. You don't need to put a drop of oil. There is enough atmospheric contaminant which contains oil and many other contamination which would act as lubricant. We'll know later on this is called boundary lubrication, and that acts well. If you do this in other atmosphere, the friction and wear will be of different types. Oxidation of the surfaces is a major issue in many cases. And in ridges and structures near the seaside, they often have electrochemical corrosion. So the atmosphere makes a big difference in the tribological system. If we slide two surfaces in an argon atmosphere or neon atmosphere, we see that there will be no oxidation, and hence those problems will be eliminated. So what I'm trying to say here is that although lubricant is important, atmosphere is also very important. The contact phenomena between the two surfaces is an important issue, and we'll learn later on that contact mechanics plays a major role in understanding the tribology of the two surfaces. As I said earlier, the chemical and electrochemical process also is important. When we rub two surfaces, there is a frictional heat generated, or the ambient temperature can also make a big difference. The heat generated would lead to a rise in temperature, and this may degrade the lubricant and affect the metallurgical characteristics of the sliding surfaces. And these are some of the causes of the change in frictional characteristics when the two surfaces slide. In this course, we'll learn all this slowly. Wear is again a very important issue, and how the surfaces wear is an important interfacial problem. We'll learn that in this course in due time. So with this, we have a very brief introduction to tribology, and this is it for today. We'll go ahead next time from here on.